Welcome, everybody, to MongoDB Podcast Live. I'm Shane McAllister. I'm one of the leads here on the developer relations team at MongoDB. Today, I'm joined by Ninad, who wears many hats, and we're going to dive into that during the introductions, and I'll let him explain that himself. So without further ado from me, let's get started. Ninad, you're very welcome to the show. How are you?
Hello, Shane. Oh, I'm good. Thank you. How are you?
Very good, very good. I'm certainly looking forward to this. Ninad, as I said in the intro, you wear many hats. I've met you in person before. I was delighted to have done that at our MongoDB.local session in London last year, where you interviewed live on our MongoDB TV channel with Harshit, one of the community managers here at MongoDB. But tell us a little bit about how you came into the foray to be what you are today now, which is a MongoDB champion for us.
Yeah, so I'm Nenad. I work in Flatfy as a senior engineer, and also I'm a MongoDB champion and a MongoDB mag leader for Serbia. I basically started as in a freelance world where I had to learn everything myself in order to be competitive on the market. And as probably everyone, I also started with the relational databases in the beginning because that is what they are teaching us in college. But when I was learning things on my own in a freelance world, I discovered MongoDB. And since I'm coming from the JavaScript ecosystem, I found MongoDB to be the perfect fit for me because the MongoDB model would directly map to my JavaScript objects. The schema was completely flexible. Because when you are developing applications, especially in a freelance, it's probably mostly startups. So application is usually evolving as the things are getting discovered. So you don't always know everything that has to be done in the beginning. So there are a lot of changes to be done. And that is where you always have to remodel something in your code, redesign the schema, or refactor the code base. But Mongo made it that perfectly simple, where you can just add a field, remove a field, or change the type. And MongoDB schema was a perfect fit for me. And since then, I was using MongoDB exclusively always.
Excellent. That's a perfect pitch that you did my job for me there, Ninad. Thank you so much. So you started to use MongoDB and you started to, contribute on our forums as well, and get involved in our wider community there. And then I've seen your name a few times on our MongoDB Developer Center as the author of some of the articles. Tell us a little bit about that.
Yeah, so since I'm practically a developer, I was visiting Stack Overflow every day, multiple times. And after I gained enough knowledge that I was pretty comfortable with, I was starting answering questions on Stack Overflow, mostly about MongoDB and JavaScript, especially Angular and Node.js, which is my stack. And eventually, people saw my answers there, and I was one of the main contributors. I started also contributing on the MongoDB forums, which is practically a Stack Overflow only for MongoDB. And that is when Veronica invited me to join the MongoDB community officially. I was not the champion back then. I was only the creator, but as creator, I was able to write blog posts on MongoDB official blog, and that was a big exposure for me. I was also writing on my own. I started my own personal blog, and I was writing about MongoDB there. After that, I was invited to join MongoDB to help MongoDB certification team by helping them create and review questions for MongoDB official certification. And thanks to Jodine, the lead for the certification team, she nominated me for MongoDB champion title, and I got it last year.
Excellent. Well, listen, we're very lucky to have you. I see you're wearing some of the swag that the champions have as well too. Yeah. So it's brilliant. Champion's job, what do you do? I know you mentioned the meetup groups of MongoDB mugs. Tell us a little bit about that, and particular to what you do in Serbia, please, Ninad.
Yeah, so in Serbia, I'm leading the Serbian Mag with my friend Alexa. So we are organizing the meetups about MongoDB topics, and we had 3 meetups so far, like with interesting topics about like RAG systems and MongoDB in general, vector searches and stuff. We are scheduled to organize the 4th meetup in February. So everyone that are from Serbia listening to this live stream, like I would invite all of you to join us there. Other than that, like on Champions, we are basically like trying to contribute as much as possible with the certification team, with writing blogs, helping community by answering their questions on various community platforms like Stack Overflow that we mentioned, and MongoDB community forums. So basically, we do everything we can to help the community.
Excellent. Well, listen, as I couldn't have said it better, and I don't think Veronica or Harshit on our team could have done it better either, Nina. That's brilliant. And as you mentioned, it's Serbia where you're running the mug. If you go to, and I had the banner up a little bit earlier, if you go to community.mongodb.com, you can go and see where we have the MongoDB meetup groups. And hopefully there's one near you and you turn up. It's a very kind of easygoing community. You're going to learn something. You're going to maybe get some beers, get some pizzas, meet like-minded developers as well too. Exactly. But if there isn't a meetup in your area, we're always looking for meetup leaders. We're looking for people who are quite happy to do exactly as you've done, Nina, is kind of say, put their hand up and say, look, I've used MongoDB. I want to meet other like-minded people. And you can create your own mug, and we've got resources and facilitators to help you build that and send you out some swag and t-shirts and everything that you might need as well too. And indeed, in conjunction with that, I mentioned it in the introduction that you had joined us on the live stream at mongodb.local. Local are MongoDB's events that we tour around the world. We used to just do marquee events in London and New York, but last year we took them to over 20 cities around the world. So if you go to mongodb.com/events, probably not populated for 2025 just yet, but if you go there in a while, you're going to see our full calendar for mongodb.locals, which is another way to meet like-minded individuals and kind of get involved in the wider MongoDB community as well too. That's a huge introduction. You've got so many hats, as I said in the beginning. What we're here today to talk is about semantic image search with MongoDB. Nina, we've got a wide audience, and I'm looking here in the comments and the people joining from Portugal, Atlanta, and Israel, and India, and Afghanistan, etc. too. And it's great. Please drop into the comments and say hello. We've got a wide audience, so talk to us a little bit. You might have heard about semantic search. We might have heard about generative AI. We might have heard about vector search. Tell us a little bit of the background before we dive in, because as I said, you have an exciting demo to show us, and I'm thrilled to see that. But why is semantic search important, and how does vectors help us do that?
Yeah, so I don't know if I should maybe start with the presentation, because I prepared a presentation where I would cover all of that practically. So maybe it's better to go like from start of the presentation up to the end, where we would gather all the necessary theoretical things for the actual demo.
Excellent. This makes sense. And I know our viewers, sometimes people are allergic to presentations. I can guarantee you, super quick, very informative, but an amazing demo coming up after this. So Nina, let me throw your presentation up on the screen there. If you want to make it full screen then as well too, I'll remove us so people can see a little bit better of the presentation itself once it loads, and you can take it away.
Sounds good. So guys, we are about to cover the semantic, in general, semantic search, especially with MongoDB, but also like in a general way. So as a high-level agenda, we are going to introduce the embedding model and what are the vector embeddings, how we can do vector search in MongoDB Atlas. And in the end, we will go through the code walkthrough and we will showcase the application demo. As an outcome, I hope that in the end you would be familiar with both theoretical and practical concepts of how to implement semantic search in any application. This on the right side is actually the application that we are about to build, but we will cover that more in the end. So introduction to embedding models. So what are the embedding models? Embedding models are the models that has a purpose of embedding the unstructured data in a way that would capture the semantic meaning, and as the output, it would produce the array of numbers. So basically, all the semantic meaning would be captured in that output vector, which is practically an array of numbers. The inputs can be any unstructured data like images, documents, audio, videos, PDF files, or whatever. So the input unstructured data, once going through the embedding model, will produce the embedding vector, which would capture the semantic meaning of that unstructured input data. And then later,
that's, I think, a really key point. So we all know about searching. And we all understand, that we can search, and we've been searching for years, as long as the internet has been around as well too. But only recently have, and when we search, we're searching for a match, or fuzzy search perhaps as well too, which is kind of like or similar to, etc.
Exactly.
Semantic search, Nenad, is we're able to derive meaning from the data. So as you said there, we can put in images, we can put in audio, or we can put in larger documents, and the vectorization, the embeddings that happen, allow us to categorize the meaning of that, essentially. Isn't that true?
Yes, exactly. So both the meanings and also the relationship. So the main purpose of embedding model is to capture that semantic meaning and relationships, and produce the output in a way that can be understood and processed by machines, which is the embedding vector.
Okay. And when you say relationships, you're considering there that similar items or similar content is stored in an adjacent area in the vector database, so that they can easily be paired or matched together.
I will cover that now in
Excellent.
this next
I got ahead
slide.
of myself. You got it. Yeah.
Yeah. So what are the vector embeddings? So as we said, embedding vectors are the output of the embedding model, which captures both semantic meaning but also understanding the relationships. That is the most powerful point. So in this example here on the right side, this is of course a simplified example. We have like words like cat, kitten, dog, or houses, which is practically here vector with 7 dimensions is created for each of them for like demo purposes. So each item in the embedding vector represents one feature of the vector, and the number here represents how that feature contributes for that whole context. So when we would like to then plot that, and for plotting, it's also used like reduction in dimension in order for us to see. We can see that cat and kitten would be really close to each other because they are semantically really similar. Dog would be close to cat and kitten, but it would be much further than a kitten from cat. But again, it is closer than houses. So we can see that this would kind of be animals and this would be something else. When I said it would capture the relationships, that is the below example is a good representation of that, where we can see that, for example, men and women are close to each other. It is the king and queen are far away from men and women, but the distance between king and queen is kind of the same as the distance between men and women. So the relationship part is maintained. So this embedding model would capture both semantic and the relationships. So where this all began. So in the 1990s, we had something called RNNs and LSTMs, that is recurrent neural networks and long short-term memory, which is a subset of the first one. They were basically used to process sequences, but they didn't work that well up until 2017, where transformers were introduced in a paper called "Attention is All You Need." And that transformers model, that is actually this image on the right side, which represents the whole architectures of the transformers models. That is where that opened the door for future improvements. And that is the base of our today's LLMs that we can see, like GPT, Gemini, Claude, Llama from Meta, and the others. So the embedding model is actually based on the architecture of the transformers, because transformers has two parts. Left part is encoder of the transformer, and the whole embedding model is actually based on this encoder part of the actual transformer. So that is basically where we got to the embedding vectors and embedding models.
Perfect. Yeah.
So what are the applications of the embedding models? There is a lot of use cases. First is natural language processing, where we can have the sentiment analysis, for example, on social media, where you would like to see about some comment, is it like a positive or negative? Then you have like a text classification. That is an example on the right side, where we have like text visualization of book embeddings, where we can see that even in two-dimensional space, as in this image, we can see that the green ones are non-fiction, and this on the most right side is the science fiction ones. So even there is a separability between the classes, even in two-dimensional space. So it is really good for search. Also, information retrieval. It is a semantic search that we are gonna cover today with our demo application. And also it can be used for example, recommendation systems, where maybe Netflix would like to suggest you some good movie based on what other people similar to you liked. So that is how the recommendation systems would be built. And also we can use it for clustering and similarity analysis.
Excellent. Great to see.
So let us start with the introduction. What are the vector databases? So vector databases are the databases that can efficiently store high-dimensional vectors and search through these vector as a whole. So we have two types of databases, like I called it here traditional databases and dedicated databases. Dedicated databases would be the ones that are covering only the vector, that are storing only kind of the vectors, and they are specialized only for vector search. On the other side, we have traditional databases that also has the vector search capabilities, among which is, of course, Mongo, that allows us to both store our general data that we would store for in our application, together with embedding vectors and ability to search, to execute the vector search, which in my opinion is much more intuitive and useful, because you don't need to maintain two different data sources. You would do everything in one data source. For example, MongoDB, you would execute vector search, but all the metadata about the things that you are searching for is already there. So easy for you to fetch and process in your application.
Yeah, and that's a really good point. And I suppose if people want to learn a little bit more, they can just go to the MongoDB site, products. You just do the drop down there and you search for Atlas Vector Search there as well too. But we launched it in June of 2023 at our .local in New York. And for us, it's been a game changer. It really allows MongoDB to leverage, the data that's already in Atlas, or the data that's not yet in Atlas, but you're going to bring it there to use in your generative AI applications. Because as you say, Nenad, and quite eloquently, your data is there, but your vectors are stored alongside the data in the same document. Whereas before, with traditional vector-only databases, such as Pinecone, for example, you were doing a big round trip. You were managing two data sources. You were essentially a lot more extract, transform, and load of your data, a lot more ETL pipelines, right?
Exactly. So now, how to measure the vector similarity between the two vectors? There are basically four main functions. One would be squared Euclidean, which is basically the closest path for closest distance between two vectors. we have a Manhattan, which is the same, but that allows us only to go on the coordinate axes. And we have cosine and dot product. Cosine is using the angle between the two vectors, and dot product is using both the angle and magnitude. It turns out that using angle is much better for high dimensional vectors than using the Euclidean and Manhattan. So that is why in most applications you would see that either cosine or dot product are being used. So now this is a little more complex, but I wanted to quickly cover it, like how the vectors are stored for fast retrieval. Basically, when we want to execute the vector search, we can have really a lot of vectors in our vector database, really a lot of embeddings inside. It can be millions and millions or even billions. So we cannot always, if for one input embedding vector, we cannot go and try to compare it with all other vectors within our database, because it would take so much time and it is also computationally expensive. So what we want to do is we want to only search in approximate nearest neighbors. So that is on the left side. That is a technique developed by Spotify, and its name is approximate nearest neighbors. Oh yeah, that is how they named it. So
okay, I didn't know about the oh yeah piece. I knew ANN. Brilliant.
And practically how that works is you would divide first the vector space into two subspaces. We can see this line here, and that would reproduce, like for us in a tree structure, like two paths. Then each of the subsets you would then divide another again by half, and then again by half, until you have meaningful small data set. And then when you have an input vector, you would see where he would fit in which lowest subspace, and then you would search nearest neighbors there. Right, so that turns out to be the much faster and computationally much less expensive. On the other side, we have HNSW, which kind of does the similar thing, but on a layer-like structure, where, for example, this is our starting point, our input. So on the first layer, we will try to see what are the closest matches for us, closest vectors. We figure out that is these three. So once we project these three in the second layer, we will try to find their closest matches, and then we will project. It is kind of similar as on the left side with tree, but instead of trees, we have layers. And these two approaches are the most used ones under the hood when we were executing the vector search.
Perfect.
So what is now the semantic search, and how does that whole process works? As we said, we have unstructured data initially as a starting point. It can be any kind of unstructured data, video, whatever. We put that through the embedding model, and we get embedding vectors as an output. Then we would store these embedding vectors in our database. And then after that, for each user query input, we would create an embedding vector from that input and try to find the most similar vector in our database from the unstructured data that we created before. And that will basically result in us having the whole semantic search implemented.
And it's key to point out, because I know we've missed this, or we got questions on this in previous kind of similar talks around vector searches, that your query needs to be vectorized using the same embeddings as your data did as well.
Exactly. Yeah, the same embedding model. Yeah.
Okay.
That's right. I didn't throw that here. It is really important. So for practical example, this is the application that we are going to build. I found like a good data set of the e-commerce products in a website called Kaggle. For ones that doesn't know, Kaggle is a really good website to find any kind of data sets that you would like to play with. And they also are organizing all the competition about like finding the best machine learning model for classification, clusterization, or for a given data set. So I took the data set from Kaggle, and then we will use the embedding model from Google, Vertex AI. And this is interesting because I will gonna use the multimodal model, which will practically allows us to both search by either text or by either input images, because this model, it's a multimodal model. It is saving the embeddings both from images and from text are in the same semantic space and in the same dimensions. So that is really important, because whatever the input is, our query, either text or image, it will be able to search in the same semantic space.
Which is ideal, and that's why, yeah, you see the multimodal stuff coming to the fore now, and you know, it wasn't always the case, but it's great to see so many.
Wasn't always. Yes. Yes.
Before we get into your demo, this has been a superb overview of everything. I'm interrupting your tech stack there. Talk through that, Ninad, before we get into
that. Yeah, I think this is the last slide for probably. Perfect. So the demo is created with Node.js on the backend and Angular. That is the software being used. MongoDB is a vector database. Vertex AI multimodal is used as embedding vector, and as I said, the data source is downloaded from Kaggle, and that's it.
I love that quote. Perfect. Just before we get into the demo, which I'm really excited to see, 2 questions really from our comments, and please throw any other questions you might have in there, and we'll take them on board if we can. So from Michael, when we had up the nearest neighbor diagram there, he asks, what if the nearest neighbor is in an adjacent part of the index, so in one of the different colors perhaps?
So that is the thing with nearest neighbors approach. We are not guaranteed to always get the perfect results. So that is kind of like a trade-off with the speed and cost. The trade-off is accuracy. These models are actually really, really good, but sometimes maybe if you want to fetch like the first 10 results, maybe it can happen that the 10th result is not the one that you would have if you actually executed the full scan throughout the whole data set.
Yeah. And I think if anybody's played with LLMs and tried to build, you know, search apps, semantic search apps, even kind of chat apps, etc. as well too, they're familiar with that. It's not always perfect, but as you say, it's a compromise perhaps as well too. But Michael, thank you for that question. One for me, really, a compliment for you, Ninad, first of all. Yusuf was inspired by your career journey. His background is JS, and he wants to add more skills, and he's looking to help sustain and boost his career. Yusuf, we have the MongoDB University. If you want to learn more about MongoDB, it's a super resource. It's entirely free, and you can go in there and take all the courses at your leisure, you can go in there and not even register and start courses, but if you register, it'll store your learning plan for you. And the only thing that if you want at the end is to get MongoDB certified, there is a fee for that certification course. But if you're a student or startups, etc. as well too, we do various packages and reduced fees. So from a MongoDB perspective, certainly go to our university. Ninad, where do you go to learn generally?
So Yusuf, you said like you would add more on the skills, and so in my opinion, like I chose my stack about 6 or 7 years ago, and I didn't want to learn anything in addition. I wanted to be expert in one thing and not to know many things a little bit. So I choose Node.js, Angular, and MongoDB as my stack, and I stick with it until today. So I would say just choose whatever you are most comfortable with, and then try to become an expert in that field. Just learn as much as possible from various blogs, YouTube tutorials, conferences, webinars, specifications, documentations, whatever you can find, just read it, and then you will be really competitive on the market in these fields.
Excellent. That's a superb answer. Stick tightly. We got a third one in while you were talking about Simon asking about the slide deck. I don't know, Nina, did you put that anywhere? But obviously, as I mentioned at the beginning, the recording is available afterwards up on YouTube and LinkedIn as well.
We can add that in the description of the YouTube afterwards. Yeah.
Perfect. Excellent. We'll certainly take care of that, Simon, for you as well too. So look, sorry for the interruptions. As Linus says, talk is cheap. Show me the code. Let's get
Yeah.
on and see this in action. Thanks, Ninad.
Sounds good. Just 1 sec. So I will just go through the server code. I also prepared the front-end code, and I will publish both in the GitHub repo together, so you can all clone it and play with it if you would like.
Perfect. And you gave me that repo link, Ninad. So whilst you're showing this, I'm going to grab that link and I'll drop it back in the comments on YouTube and LinkedIn for people.
I want to mention that I still didn't push the code, but I will push it later. So the link will be the same. The link will be the same.
Perfect.
So I would start by bringing just showing the data set that I found on Kaggle, and that covers the e-commerce products. There is about 44,000 products, and you can just download it from Kaggle. But for your convenience, I already downloaded it and I parsed it as a JSON, so it is already inside the server repo for you to just take. It is it's here, and it's already structured. So the first thing for us to start with is when we have this data set, we would of course want to model our database. So we need to create a products collection, and we would like to model it. As you can see here, I mostly modeled it to be one-on-one with the data set from Kaggle, except I added additional property, which is image embedding, that we would like to implement our vector search around. Once we have that, and we have our database created and set up, I would recommend everyone to use Atlas. We can now start with the actual logic. I implemented 3 functions for you here. One is to import data to the database. One is to actually go and create embeddings. And one is later to search the products that will be used in our front-end app. Importing the data is really easy, only a few lines of code. So you will just parse that big JSON file and then just insert all the items in the database. It will take only around 10 seconds probably for all 50,000 records to be inserted. Second part is the actual part where we will create the embeddings. But before we create the embeddings, we would like to create a vector index. And I would like to show you how to create a vector index. I already created one before the demo. But basically, when you open the Atlas, you need to create a project. I've already created one. It's called Image Similarity E-commerce. And then when everything loads, you would like to go here to browse your collections. Of course, you need to create a cluster first. And here you can see all your collections. You can see that products are here, and there is 42,000. You would want to go to Atlas search section, and that is where the vector search should be created. You can see here that I already have my vector search index created, but if you want to create your own, you need to go here, create search index, and it will ask you 3 different things. The first 2 are related to Atlas search. The third thing is related to the vector search. So you would like to select the third option and click next. And here you need to name your index. You can just name it, for example, index 1. The fields should be like this. The type should always be the vector. The path should be the name of the field in your collection where you will store the actual embeddings. So in my case, the field was called image embedding.
Okay.
The dimension is the dimension that has been used by the embedding model. And in our case, it is 1408. That is the dimension being used by Google's Vertex AI, which is multimodal.
Okay, and that's depending which models you're using. And MongoDB vector search supports up to 4096 dimensions.
Exactly.
Okay.
And the last thing is for you to choose the similarity function. As we said, there can be 4 of them, but in most things you can use either cosine or dot product. And after you finish that, you need to select also on the left-hand side on which collection you would like this search to be created, and then you click next, and it will create the index for you.
Mhm,
I'm not
mhm.
going to do that because I already created the index before. And after we have that vector search created, then we can continue with our actual code. This function create embeddings, so you can execute it by just calling this endpoint, which is exposed to you, will do the following. So it will fetch all the products from our database. And remember that we already imported all the products in our database that already doesn't have the embedding added to it. And it will project only the image back. We are projecting only the image because we want to create the embedding of that image so the semantic meaning is captured of what that product actually is.
Okay.
Since we
That's a really
have
good
a lot
trick
of
insofar as you're only looking for products that don't already have the image embedding field. So does that help, say, if that data set got updated with more products in the future?
yeah,
You could set a trigger, for example, to go back through and find the ones that haven't had
exactly.
embeddings added.
Yeah.
Okay,
Yeah.
perfect.
So here I specify the batch size because we have about 50,000 products. It would take a long time to maybe about 1 hour for all the products to be processed, because for each product we need to call Google API to get the embeddings from and to update the document inside the MongoDB. So I implemented here a batch processing, which will basically create a batches of 50 products and processes the 50 by 50. Depending how powerful your machine is, you can increase this and reduce the time necessary for everything to finish.
Yeah,
so
I was going to ask why you selected 50, but it's just from experience yourself, basically.
Yeah, I just randomly added that. Yeah, I had
Okay.
time. So now we are processing all the batches here, and first thing for us is to fetch the actual image from the data source, and we want to fetch it as an array buffer. And now we want to create a base 64 representation of this image, because that is the format that Google will accept when we would ask Google for the embeddings. And now we just construct the prompt. We specify the publisher and the model, which is necessary for Google typings to work. And here we are calling the Google API to actually get us back the embeddings. You can see here prediction service client. Let me go up in this code. We defined it above in the start of the code. That is basically a official Google package that we can use to help us do these things faster.
Ideal, perfect.
Google will return us back the predictions, and inside the predictions, we will get our actual embeddings. Since Google is returning like a deeply nested structure, we actually have to access nested fields to get the actual embeddings. But after we do that, we have the final embeddings for this particular image, and we want to update the product with it. So we are updating the image embedding field, which is the field that we specified when we were creating the vector index in Atlas. And after all the products has been processed, then we are ready to execute the actual and search our actual products semantically. The third endpoint is created for that, to search the products. We have this here, a middleware that will parse the files if file is uploaded. So we can, as we said, we can query both by text and by images, because this is a multimodal model. And the search is kind of easy. So we have a text query potentially, or the file. One of these two has to be present. And we will construct the prompt. If the text is passed to the backend, we will construct the text prompt. And if not, we will construct the image prompt. Then we will just call Google to create the vector embedding of our input prompt. And depending on if our input was text or image, the Google will return it in a different field. So it will be either in the text embedding or in the image embedding. But as we said, this multimodal will in this image embeddings and text embeddings, both will be in the same semantic space by using this multimodal model. So both will work the same.
Perfect.
And here we are constructing the actual query for our MongoDB. The first stage in our aggregation pipeline will be the vector search, where we say that we don't want exact match. As we said, we want to use the nearest neighbor approach because it is much faster and the accuracy is probably not 100%, but it is near 100%.
Sure.
Index is the name of the index to be used. We specified how many items we want to be returned back, the path to our field inside the collection. Number of candidates is the field that will specify how many nearest neighbors the query will consider when returning only the 15. It is a good practice for this number of candidates to be about 10 to 13 times larger than the actual limit. And then in the end, we are passing our search embedding, so input embedding of our input as a query vector. And this first stage will return us back 15 documents. We don't need to return all the fields to the front end for the demonstration purposes. We want to project only the name and the image because we don't want additional networking from front end to back end.
That makes sense.
From back end to front end. And that is it. That is basically the whole business logic. So it is really easy to implement something this powerful. So as we can see here in 150 lines of code, everything is done.
Brilliant. Yeah, super clear. So we took our data set, we created the embeddings by sending them to the embedding model. This instance, it's Google, but it could be any. And obviously you're free to choose. And, Atlas Vector Search doesn't care what embedding model, you just define it what it is. And then when you do that and you created the embeddings, you obviously have to create your queries, and your queries need to go through the same model. And then we're going to see this all in action now, right?
Exactly. Yes.
Perfect.
So this is the server code. I also have a front-end code, which is here, but I will not go through it. It's a really simple Angular app with one component. But I will, as I said, the GitHub repo will contain both.
That's it. And I threw up the links already. And obviously, as you said earlier, Nina, once you push it, that'll all appear up there as well, too. And I know you said you didn't want to go through the front end stuff, but do appreciate the branding that you've put on this, our brand police here in MongoDB. We'd be super happy. I appreciate that.
Yes. So this is basically the simple front-end app to demonstrate what we have built now. This is now built in my local, both the front-end and back-end app are live. So this is like a live demo. So we have in our Atlas about 40,000 products. It's all e-commerce products, so various t-shirts, shoes, belts, watches, or whatever. So let us start by searching first by text, and then we can switch and search by image. So
Nina,
we can start.
Go back to Atlas there for a second, just to maybe it's loaded, but if you could pick one of the collections or one of the documents and just show the embeddings in there for that product, just for people to get familiar. We show the numbers in your presentation, etc., etc. But when it loads, I will use Compass is already there. That's perfect.
Yeah, so Compass is already loaded here, so we can see that. All the documents now have the image embedding populated, and it is like an array of 1,408 numbers, which are floats. So that is basically embedding vector for us.
Perfect. Yes. And don't worry, nobody's supposed to understand them or be able to read them or make sense of them, but the embedding models do.
Exactly. And that is why you usually want to, in my code, this is why I added the project step, because I don't want the whole document to be returned, because it would also include this image embeddings. So there will be additional 1,000 numbers passed from backend to front end, which will increase the networking and latency. So that is why it's always a good approach to just filter what you actually need for your actual front end app. And let us start by doing something in our front end app. So let us, for example, search by t-shirt, and we can see all the t-shirts here. So we can add t-shirt for women, and we will now see all the t-shirts for women because like semantically it recognized what are the women in the images. We can also add, for example, pink. So it should return all the t-shirts with pink colors. And we can even go further, like with cartoon character. So it is smart enough to actually add that as well. So we can also
and it's super
go
fast. I mean, I know it's running locally, like, but you still have 40,000 plus items, right?
Yeah, exactly. It's really fast.
Wow.
I mean, I'm running the server locally, but MongoDB Atlas is being used as a database that is not locally, so it is super fast.
Yes.
Yeah. So
even better then. So
we can see that actually works really, really good, and the semantic meaning is really captured properly. We can also go with like belt for man. We can add like color, and we can see that it works really, really good.
if anyone wants to make sure that this is not a canned demo and Ninad hasn't tested all of these searches himself already to know that they're good, pop a search in a comment. Let's have a look.
Exactly. We can also try image search. I downloaded a few images from the internet. So, for example, we can upload the image of the watch. We can search, and we can see the actual watches are returned, but not only the watches itself, but it recognizes that the watch is kind of silver, so it returns us all the silver watches. So I have another one, for example, like this, a T-shirt, like it recognized the Mickey Mouse, so it also Mickey Mouse and everything. So basically, it works really, really good, and it took us only like how much? Maybe half an hour to cover everything. So anybody can build now really amazing applications really quickly. And this is much more powerful than what we could do before vector searches. We could only search by like keyword, like similarity or something, or exact match, or maybe something like that with Elasticsearch. Or this is much more powerful and much better user experience for user to actually describe with text what he actually wants. He doesn't have to go through various categories, filters, and navigate the website to find actually what he wants. He can just go and type or like upload the image of something similar that he managed to find, and he finds the most relevant matches.
Yeah, and semantic search has made things so much simpler. Like in the past, going back to do something like this, you would be either, making sure certain words appear in the product description, for example, or you'd be adding extra keywords, or you'd be adding extra filters in there as well, too. And the other side of this, I suppose, too, then is the fact that it can, what was I going to say on this bit? We could do the reverse as well, too. In other words, you could take an image, upload that to get, and ask for it. Can I have a text description of this image, please? Which then can be used to add text into the description if you weren't doing semantic image search as well, too. So there's so many variations of how you could go about this, but it's been a superbly clear, easy demo to follow, Ninad. So it's been great. And as I said, if anyone else wants to make sure that this is proper and true, please pop in an appropriate search into the comments and we'll use it. If it's inappropriate, it ain't getting on the screen. So perfect. Anything else to add, Ninad? I know that you worked on this and you pulled this together in really quick time, and you showed us, a couple of files, 150 lines of code here and there, then the UI obviously as well too. You're an experienced developer, but for somebody looking to try this out with your repo, for example, as a basis, how could they could easily choose a different data set and spin this up themselves, right?
Exactly. I will document everything in the GitHub repo in the README file. So the actual having the repo up and running is really simple. Just navigate and execute two commands: npm install to install the packages, and npm start to start the server. So that's it. But perfect. I will document everything.
Zhao took us up on our challenge. So colorful socks for men, Ninad.
Let's try.
Let's see.
How do you spell this?
Colorful, C-O-L-O. Well, in American is O-R. Irish, there's a U in there, but don't worry about that. C-O-L-O-R-F-U-L. Socks for men. S-O-C-K-S.
So
There you go. And you got boxes of socks and everything. Ah, brilliant.
Yep.
Brilliant. Excellent. And we got another one, which the name didn't come through into StreamYard, the platform that we're using. So I do apologize. T-shirt with the green leaf. I've got a sneaking suspicion this person works at MongoDB, perhaps.
Yeah, I don't know if the dataset would contain this, but it does, kind of.
Yeah,
Maybe.
not bad. But look, there's other green T-shirts, there's other green logos. It's getting it. So there you go. Nice one. See, so it's not a canned demo. It's a fully live demo. Nina, it's stood up really, really well. We did have one question, and I don't know, like the accuracy. This is a question from Gabrielle. How is the percentage of accuracy? How would you address that? Because it's not always about being accurate. It's about, when we come to semantics, it's the meaning. It's not like matching 100%, 100%, right?
Exactly. So that is, the accuracy is hard to actually figure out here. I don't know if you are meaning like the accuracy of what the output should be, or how much accuracy is lost by using the nearest neighbors instead of actually going through the whole data set, because that makes more sense other than what is the percentage of accuracy, because there is not kind of accuracy in this approach. Like nobody can say that this T-shirt is more accurate than this one, right? It's
true. I suppose, Gabrielle, if you have any other to add to that, do drop it in there. We still have a few more minutes left on our live stream. But yeah, and I think a lot of these things are a little bit of trial and error. Build it. As you can see, building something quickly is easy. And also you might decide, that, and we know this, some embedding models are better at certain tasks than other embedding models. So it's really about choosing the appropriate embedding model for the application that you're trying to build as well, too. One more challenge for your search, which was electric guitar. Nina.
I don't think in the data set contains that, but let us try.
No, but it might be on a T-shirt, right? Maybe. Let's have a look. Yeah. There you go.
No guitar, but it found it in the T-shirt.
Found it on the T-shirt. Excellent. The others are a bit funny, all right, too. But yeah. So here, that goes back to the
that is because I didn't. So guys, you can also add the additional stage after the actual search. So I returned I am always returning 15 results, but you can also filter out the results later based on the vector score that is generated for the similarity. So you will get for each returned document a similarity score that you can use as a filter for the next stage. So maybe, like, obviously maybe guitar would pass that filter, but everything else would not in this case.
Yeah, that's something you do see quite a lot in generative AI apps. They'll have a thumbs up, thumbs down, because you're trying to get that reinforcement learning going on too in terms of results, right? Perfect. Nina, this has been super clear, to go through from the theory all the way through into the code and all the way through into a demo that held up for this quite discerning audience that we have today. It's been brilliant. Anything else to add as we wrap up and close out in terms of your own thoughts about, how easy this was to build, what you might add to it in the future, perhaps?
Yeah, so I mean, it took me one day to build the whole thing. It is the hardest part is just going through the documentation, especially Google one. Google has always a confusing documentation for me, and complex and multi-pages, and like you need to go here and there to just fit all the pieces together. But other than that, like, everything was really easy. Basically, the only thing you need is data. So to find a good data set that you can play with, that is like really important. So that is why I always suggest go to Kaggle. Kaggle is a really good website to find that.
Excellent. And Jai, thank you for your lovely comments as well too. We do appreciate everybody who joins us on these live streams. We try to do, as I said in the introduction, do them regularly. My show, this podcast live essentially, though there are other hosts as well too, is every Tuesday. So do keep an eye on that. Before we wrap up, a little plug back for the mug in Serbia. You think it's going to be in February, sometime in February, you're going to pull that together?
Yes, probably in February, and I think like my friend Marco, that is like the author of MongoDB book, will be the speaker. So I would like again to invite everybody to join, whoever is close by.
Perfect. And to find out about that and other mugs, depending on what area of the world you are, just go to community.mongodb.com into our site there, where you'll find our mugs, you'll find our forums, you know, where Nenad said he started answering questions in forums after he built up his experience in Stack Overflow and moved across to the forums to say, well, look, I'm going to concentrate on these MongoDB answers and everything else that goes on there as well too. And if what Nenad showed you, as we mentioned in his introduction, he has some articles up on our Developer Center, as do the rest of MongoDB, our developer relations team, our product engineers, etc. as well too. So if you want to learn more, the simplest place to go to is developer.mongodb.com, and you'll find everything. You can use a filter in there to look for generative AI. You can look for the tech stacks if you're Node, if you're, you know, whatever you want to be, jump in there and filter by those as well too. So they're the two good links that we'd like you to take away from today's show. Community.mongodb.com for everything to do with our mugs and our meetups and everything we're doing out in our developer community, which is superb. And also developer.mongodb.com to learn more. Nenad, any final words for our audience today? And I just have to say thank you so much. You made my job super easy with all the effort and work that you put into this stream for me.
Yeah, I also just wanted to say like thank you for everybody that was watching us, and I hope that you like it.
Perfect. Well, look, as we posted earlier in the comments, and they will stay put, the repo that Nenad will push to later will have everything that you can go in and play around it yourself. I'm assuming you're looking for any comments, any PRs there as well. If people want to improve on what you have as well too, you'll happily take those on board, Nenad?
Of course, it will be public repo, so anybody can contribute.
Excellent, excellent. Well, listen, that's been great. It's been a pleasure to have you on board the live stream. I know you joined us in person before. I'm sure you'll be back again in the future, Nenad. So this has been a pleasure to have you on board. And to all our viewers who join us on LinkedIn and YouTube, thank you so much. Somebody has asked, is the recording available? As soon as this stream ends, well, give or take a couple of minutes, you can go back into LinkedIn and go into the events tab, and you'll see past shows and you can watch this again. Or you can go up to MongoDB's YouTube, it'll appear there as well too. And I do believe as of recently, we've got a MongoDB Podcast Live playlist up there as well too. So this and everything else we've done over the last nearly 2 years now should be available up there as well too. So that's the end of the plugs. Nenad, thank you so much for all the effort and how clear you made everything. So really appreciate it. I hope you enjoyed it.
I enjoyed it. Thank you for the invitation.
Excellent. So for me, Shane McAllister in Dublin, MongoDB's office here in Dublin, Ireland, to Nenad in Serbia, and to all our viewers all around, thank you so much for joining us. Keep an eye out for the next streams that are coming your way for more massively entertaining and informative content such as this. Nenad, thank you so much. It's been a pleasure. Take care, everybody.
Bye-bye.
Bye-bye.